In the last lesson, we worked on conversions of measurement. Now we're going to use unit price and related measurement conversions. There's cups of blue paint and cups of red paint, and the ratio of the cups of blue paint to the red paint is 1 to 2, which means that for every 1 cup of blue paint, there are 2 cups of red paint. In this case, we could write an equation that would be red is equal to 2 times blue, or R, being red, is equal to 2B, B being blue. Let's make a table of some values according to this equation. Okay, here's our table. What are the 2 quantities or the 2 things we're comparing? Right, cups of blue paint and cups of red paint. We know that for every 1 cup of blue paint, we are told that there are 2 cups of red paint. What about if there are 2 cups of blue paint? Well, let's look at our formula. R equals 2B, or red is equal to 2 amounts of blue. Oh, red is equal to 2 amounts of blue. So blue is 2, so 2 amounts of blue would be 2 plus 2, that's 4. If we have 2 cups of blue paint, then we're going to have 4 cups of red paint. What about if we have 3 cups of blue paint? Well, red is equal to 2 times the amount of blue. Blue is 3, 2 times that amount is 6. If we have 3 cups of blue paint, then we'll have 6 cups of red paint. And what about if we have 4 cups of blue paint? Yes, you've got this. We would have 8 cups of red paint. Okay, Ms. Sipple, she's a librarian who totally loves reading. She can read 3/4 of a book in 1 day. This relationship of her reading amounts of book to time can be written in an equation of D equals 3/4 of B, where B is the number of books and D is the number of days. Well, we could say that the amount of days is equal to 3/4 of the amount of books. Okay, let's throw all of this in a table just like we did with the other one. And we're dealing with numbers of days and numbers of books. If she read for 1 full day, then how many books did she read? Oh, well, our original ratio told us that. She reads 3/4 of a book in 1 day. Okay, 3/4. What about if she read for 2 days? Oh, that would have to be 2 times the amount of books. What is 2 times 3/4? Aha, that would be 6/4, because 3/4 plus 3/4 will give us 6/4. But wait, we can also write that as 1 1/2. What about if she read for 3 days? How many books would she read? Well, 3/4 a book for 1 day, so we need 3 times that much. Aha! 3 times of 3/4 would be 9/4, or 2 1/4. And so on we go. 4 days of reading would be equivalent to 4 times the amount of books she read for 1 day. 4 times 3/4 is 12/4, or 3. Okay, now we have Brian and Shanice, and they are training for a bike race. They want to compare who rides their bike at a faster rate. Both of these guys are using their phones and an app on their phone to record their times and their distances of the rides. Now, Brian's app keeps track of his route on a table. Shanice's, though, keeps track of it on a graph. And so we can see it here. Here's Brian's information, the number of miles that he bikes and the number of hours that it takes. But Shanice's is on a graph and looks like this. Here's her number of miles and the number of hours it would take her. What is the rate of each of these bikers? And let's explain how we can find this. Okay, so to solve the problem as whose rate is faster, I'm going to use yet another way to display information, a double number line, because remember we're dealing with 2 quantities. We have hours and miles. And so Brian, on his table, I can see that at 3 hours, he bikes 75 miles. So I'm going to put that first on the table. Now, what if I wanted to find out how much miles he would bike in 2 hours? Well, he would be biking a total of 50 miles. But how did I come up with that? Well, if the original data is 3 to 75, if that's the ratio, then I can simplify 3 to 75 because I know that 3 and 75 can both be divided by 3. And I know then that 3 divided by 3 is 1, and 75 divided by 3 is 25. So each mile is worth another 25 miles. So if he goes from 3 miles down to 2 miles, I need to subtract a group of that 25. 75 minus 25 will give us 50 miles. And if I subtract another 25 for my next hour down, then I will have 25 miles per hour. So, Brian travels at a rate of 25 miles per hour. To compare Brian to Shanice, we need to know how many miles she can bike in 1 hour. Well, let's look at her graph. There's 1 hour. How many miles did she bike? We follow that 1 hour up to her slope. We see the point on the slope that intersects, and we follow that over to the number of miles. That's right in between 10 and 20. Oh, okay, so Shanice at 1 hour is biking 15 miles. So, Brian travels at a rate of 25 miles per hour, and according to Shanice's graph and her data, she bikes at a total of 15 miles per hour. So we know that Brian has that faster rate. But Shanice, she wants to win the bike race. So to win this, she needs to know how fast she has to go in order to beat Brian. Let's make a new graph to show the speed Shanice would have to ride in order to beat him. So, get our graphs out. Let's label them up. We're going to have numbers a mile on the x-axis and the time always on the bottom on the y-axis, and that's the number of hours. This whole graph is going to be hours versus miles. And I'm going to label my x-axis in jumps of 15, and my y-axis, I'm going to put it in jumps of 1 hour. If I want to make a slope that shows a rate that's faster than Brian's, then I need to remember what was Brian's rate. Oh yeah, it was 25 miles per hour. Well, what's faster than that? Well, I don't know, let's go up to 30 miles per hour. So I go to 1 hour and where it intersects with 30 miles, and I put a dot. And I go another 30 miles, and I go to the next hour, and I put a dot. And I continue this on until I have a number of dots which I can then trace or make a slope with a ruler. And I have now made a graph that shows Shanice traveling at 30 miles per hour, which is faster than Brian's 25 miles per hour. Let's now look at a department store where Braylon and Tice are working, and they are paid there by the hour. So the manager told both of these guys that they're going to earn the same money per hour. But Braylon and Tice did not agree. They kept track of how much money they earned, and they wanted to see if what the manager said was true. Here's their data. When Bryce recorded his data, he recorded it like this. M, which shows the amount of money, is equal to $10.50 an hour, where H is the hour. That's Braylon's data. Tice's data, on the other hand, is shown like this. He recorded it where the numbers of hours on the top of this table and how much he makes per that number of hours on the bottom. How much money did each of these boys make in 1 hour so that we can compare them? I'm going to throw their data on a double number line, both of their data, so that we can compare it. The two quantities being compared are hours and dollars. And because I want to know how much per 1 hour, I'm going to start with 1 hour. And I'm going to move to 2 hours and 3 hours only because on Tice's table, I see that he has 3 hours there already. Tice makes $34.50 for every 3 hours. So I can put that down. Now, how do I know how much he makes in 2 hours? Well, if I take 34 and 50 cents and I divide it by 3, because there are 1, 2, 3 units there, then I'll know that it's $11.50 per hour. So I can subtract $11.50 from my $34.50 and get 23, and do it again and get $11.50. And so it is correct for us to say then that Tice earns $11.50 every hour, whereas Braylon earns $10.50 per hour, because his data says, look again at the top, that for every hour there is $10.50 made in money. So, was the manager correct in his statement earlier that the boys are going to make the same amount per hour? Why? Or why not? No, the manager was not correct, because Tice is making how much? $1 more than Braylon every hour. Claire and Kate, they are entering a cup stacking contest. And both of these girls have the same strategy. They're going to stack their cups at a constant rate so that they don't slow down, not even at the end of the race. Now, while practicing, they keep track of their progress, and it's going to be shown below. Here is Claire's data. the number of stacked cups versus the amount of time. And here's Kate's data. She's using a formula. She's saying C, where C is the number of cups, is equal to 4 times T, where T is the amount of time. According to both of this data, what is the rate for each girl stacking in their sessions? Let's start with Claire. If I look at seconds, I'm going to look for 1 second because we want to know the rate, right? We want 1 unit. So 1 second, I go up and I see that it corresponds with 5 cups. So Claire stacks cups at a rate of 5 per second. Kate, on the other hand, according to her formula, is stacking 4 cups every second. Uh-oh. Kate realizes she's not stacking her cups fast enough to beat Claire. What would Kate's equation look like if she wanted to stack cups faster than Claire? Well, your answers could be many different things, but we could say simply 1 unit more than Claire, so Claire is doing 5 cups every 1 second. So Kate would have to at least do 6 cups every second. Her formula then would be number of cups is equal to 6 times the amount of time. So what all have we learned today? When we compare rates and ratios, it's best for us to find a unit rate, right? To find how much that is valued at every 1 unit. And lastly, that we can compare unit rates across things like tables or graphs and equations.